Hello class, Kifkon. Today we're gonna discuss and we're gonna talk about chapter 7. I've already done this in class, but I'm gonna do it again for those who couldn't make it. This chapter is about our solar system. So in this chapter we're gonna define what makes up the solar system, and we're gonna also talk about the properties of the different objects that are found in our solar system. Remember, if you want to talk about the solar system, you should talk about the components that make the system itself. And so the solar system is made from the sun, of course, which is the largest body in this system. It's also made from 8 planets, and this goes from Mercury all the way to Neptune. It's also made from satellites. When I say the word satellite, I mainly mean the moons of the planets. Earth has 1 moon, other planets have more moons than Earth, and so on. So this is something we're gonna also discuss later. The solar system is also made from the asteroids, from the trans-Neptune objects, and from comets. So the list you see here all combined together makes up our solar system, and in the next slides we're gonna talk about each one of them, and actually we're gonna focus more here on the asteroids, trans-Neptune objects, and comets, who come in satellites. So here we go. We start with asteroids. So asteroids are pieces of rocks found in space. Just like Earth orbits the sun due to the gravity, these rocks also orbit the sun due to the same reason, due to the gravity coming from the sun exerted on those asteroids. If you look in this image here, you realize this is the sun, you have Mercury, Venus, Earth, and Mars, and then you have this these rocks all orbiting around the central part around the sun. Now this area here is what we call the asteroid belt, because this area is full of asteroids. Asteroids are rocks orbiting the sun that couldn't make up planets. There are millions of asteroids in our solar system. We try to take images for all of them. We try to label them. We try to monitor these asteroids, because people are always worried, or scientists are always worried, that one of these asteroids might come towards the direction of Earth, and of course this will cause many problems here. This is what we call the asteroid belt. And if you notice that the asteroid belt is found in the area between planet Mars and planet Jupiter. These asteroids also come in different sizes. They can be really small, and they can be very, very large, something up to 900 or 1000 kilometers, and this is a lot of space for an asteroid, lots of area for an asteroid. So yeah, this is the section about asteroids. Now if you think about it, if all of these rocks would combine together, they would form one very large rock, and we would have called it a planet. But since these objects couldn't really stick on each other, we were left with many pieces of them in different sizes. So yeah, how little asteroids. Here again you can see a better image of the asteroid belt that you can obviously see here. These are more images of some of the asteroids. Some are really small, you can see here. Some are very large. One thing you can also notice, you see the craters. I'm pointing them with the mouse. So here you have all these craters, and these craters are very similar to what we see on the moon, and these are due to the collision of smaller asteroids on these bigger ones. Again, the reason why we can still see these craters, although they've been there for billions of years, is that these asteroids have no atmospheres, they have no activity, just like our moon. So if there's a crater on those bodies, they will stay there unless something comes up and hide them. So yeah, this is about the asteroids. Now the second thing we want to talk about when it comes to the solar system is what we call the trans-Neptune objects. Now we have we have many objects in orbit that is beyond the Neptune's orbit. Yani, if you look at the solar system, here you have the 4 planets, you have the asteroid belt, you have 4 outer planets, and then after Neptune, beyond Neptune, you have more asteroids. Now, asteroids found in this region are what we call the trans-Neptune objects, yani objects orbiting the Sun beyond the orbit of Neptune, means trans-Neptune object. Another name we can give for those objects is Kuiper belt objects. Just like we have asteroid belt here, asteroid belt objects, we also have Kuiper belt objects. So asteroids found in this region, in the Kuiper belt object or in the trans-Neptune objects, these mainly contain rock and ice. Of course, they contain ice because they are really far away from the Sun. Look at the distance between the Sun and the Kuiper belt objects. So if they had some sort of ice material, the temperature here is very low, so the ice will stay ice. An example of trans-Neptune object is Pluto. Look here, Pluto is found in this region. It is between Neptune and the Kuiper belt, so it's right there. Remember, Pluto is not a planet, it's a dwarf planet, or you can just say that Pluto is a trans-Neptune object. And here you can also find another dwarf planet, and weirdly enough, the name of this planet is Makemake. Okay, so we have lots of these objects, thousands and thousands of them. It's very hard to detect them, to see them, because they are really far away, they come in different sizes, and so on. It's very similar, the Kuiper belt objects are very similar to the asteroid belt objects. Akid Horn temperature is higher than here, so you have different structures when it comes to ice and other materials. But yeah, it's the same concept. These are also the leftovers that couldn't make up planets. Here you can see images of some of the trans-Neptune objects. Again, Pluto appears here. Pluto, the dwarf planet, also has a moon. It's called Charon. Anyway, you don't have to remember all of these, but you just have to have an idea about these objects. Now, the third thing we want to talk about are comets. Now, comets are really, I tend to think of comets as asteroids, moving asteroids, but well, let me say this again. You know, all asteroids in the end are moving. If we go back here, all asteroids are moving around the Sun, so they are all in motion. But assume that 2 asteroids would collide with each other here, and by chance you get an asteroid going in this direction, moving really, really fast. Now, if an asteroid is moving towards the Sun, it's gonna go all the way, and it's gonna orbit around the Sun, and then it's gonna go back to the trans-Neptune region right there, and then it will come back, and then it will do another orbit, and so on. So an asteroid that moves towards the Sun, okay, it's gonna be called a comet. You notice here I have a comet. This comet might have originated from this belt or from a region beyond that belt. So comets are moving asteroids. They are moving towards the Sun, and because they are moving really fast, and they are getting closer to the Sun will heat and it will increase the temperature of these objects, and what we will see is something like this. You're gonna have white tail of dust. This is due to the rocks being evaporated from the surface of the comet, which will be somewhere here, and then you will have another tail of gas. Now the bluish tail of gas here would be the ice that is being melted, again because this asteroid is moving towards the direction of the Sun. So this is the idea of comets. يعني إذا بتفكروا فيها, asteroids, trans-Neptune objects, and comets are really the same thing. Yeah, and some comets come from the Oort cloud instead of the Kuiper belt. So I have, let me go back here. This is the Kuiper belt. There is a cloud here, or a region beyond the Kuiper belt, what we call the Oort cloud. It's really far away from the Sun, and it has lots of asteroids, and every now and then we get a nice asteroid coming towards the direction of the Sun, and it will be called a comet. So yeah, this is all about asteroids, trans-Neptune objects, and comets. Now remember, the solar system is also made from the planets, of course. and the sun. So here we're gonna talk about the differences between the planets. Don't worry, I'm gonna discuss these points here. So here's the thing. This is the solar system. You see, this is planet 1, 2, 3, and 4. Mercury, Venus, Earth, and Mars are small planets. They are rocky planets, and they all resemble Earth. They all have structures similar to the structure of Earth. معقول إنه they are exactly like Earth, but they are rocky planets, comparable sizes to the size of Earth, and they have the very similar structure of Earth. So wholly what we call the inner planets. Now remember, between Mars and Jupiter we have the asteroid belt that we have seen earlier, and then beyond Mars you have Jupiter all the way to Neptune. These are what we call the 4 outer planets, and these planets are gaseous compared to those rocky planets. Now let me show you this. Wait, yes, here. So in this slide you can see the differences between the 2 categories of planets. So again, whole in the inner planets, the first 4 planets, wholly 4 outer planets. These 4 are what we call the inner, or the terrestrial, or the Earth-like planets, yani rocky planets. And these resemble Earth, so they look like Earth. أما هون, these 4 outer planets are gaseous planets, كلهم made from gases, not rocks like these ones. And these planets really look like Jupiter, so what we call Jovian planets. You can easily notice that the Jovian planets here are much more larger than the inner rocky planets, because these planets are rocky while these one are gaseous. And in the solar system, the nebula that formed the solar system had more gases than rocks, and thus the planets that are rocky-like will be smaller than the planets that are made from gases, because gases are more abundant in our solar system and also in the entire universe. And I have listed here the different properties of those planets, the inner and the outer planets, or the terrestrial or the Jovian planets. Remember, these are different namings that we give for the planets. أتذكركم terrestrial planets هني the first 4, Earth-like planets, these are rocky planets, and these are made from rocks, so they have higher densities. أما هون the Jovian ones are the outer planets. They are really large, they look like Jupiter, so we call them Jovian planets, and they are made from gases, so they have low densities. Yeah, so these are the main differences between the inner and the outer planets. I hope it's clear now. Come in, just one more note about Saturn. You see these rings for Saturn, holy rings made from rocks and ice. مثل ما في عندي asteroid belt and the Kuiper belt orbiting around the sun, I have asteroids and ice orbiting around Saturn. لأنه all are very close to Saturn, so they are locked in its gravity. ما في شي بدكم تحفظوه هون, of course. I never ask you to memorize numbers and stuff, but it's good for you to have an idea about about the distances between the planets and the sun. شوفوا هون in this little region to the left, عم بتطلع, in this little region I have the 4 inner planets that are really close to the sun. But then once you go to Jupiter, Saturn, Uranus, and Neptune, you realize that these gaseous planets are really far away from the sun. As an example, Earth, which is found here, which is at 1 AU from the sun, in comparison with Neptune, Echer planet, which is 30 AUs from the sun. So yeah, this is just for me to show you, to have an idea about the distances between the sun and the planets. وتذكروا انه Neptune كتير بعيد عن sun, so it will feel less gravity from the sun, so it's gonna move really slowly around the sun. Yeah. So حكينا عن asteroids, Neptune objects, comets, and planets. Now we're gonna talk about satellites, يعني the moons of planets. هلا برجع لهون. Let me take you here. Yes. So when we look at planets, we realize that some planets have satellites while other planets have no satellites, and the number of satellites really varies when it comes to different planets. This list of planets from Mercury to Neptune are in order. And the Mercury, we see no moons of Mercury. Venus ما عنده moons. Earth has one more, maybe more moons, you never know. Mars has 2, Jupiter 66, Saturn more than 62, in the 70s, Uranus and Neptune. I just want you to see the pattern here, that تذكروا انه هولي Mercury, Venus, Mars and Earth and Mars are the smallest planets. And it is obvious that the smallest planets have the least number of moons. And this should make perfect sense. لأنه the smaller the object is, the less gravity it will have. And the less gravity it has, the less material it can pull and lock. يعني if you think of Jupiter is the largest planet. Jupiter, I'll go back here. Jupiter, yes, here. Jupiter is very large. So any object that would be passing, let's say, in this direction, it will probably be influenced by the gravity of Jupiter, and thus it will be locked in the orbit of Jupiter. مشان هيك planets that are really large will have the tendency to have more and more of satellites. You know, they have lots of gravity, so they can pull more stuff into their orbit, and they will lock those materials, and then we call them moons. إذا بتطلعوا على first four planets, they are really small, so they can't catch many asteroids or many satellites. مشان هيك they will have less number of satellites. So Mercury ما عنده moons, كتير صغير, ما كتير بيقدر يلقط, and if maybe it had a moon before, maybe the sun would have evaporated that moon due to the radiation, and it's very close to the sun. Venus has no moons, Earth has one moon, Mars has 2 moons, and then those planets have many moons. When I say a moon, يعني satellite, يعني an object that orbits around a planet, whether it's Jupiter, Saturn, Uranus or Neptune, ما بيفرق. But this is the definition of moons or satellites. This is an image, بس لفرجيكم نحنا we were talking about this here. Okay? Oh yeah, and here are some images of some of the satellites in our solar system. هذا المون, this is Europa, Callisto, Titan, and so on. شوفوا أشكالهم غريبة. They have different structures, different properties, different sizes, مع إنه هول كتير كبار in comparison to other moons. Yeah. So هوني the example of Saturn. هيدا Saturn, the gaseous planets, the rings of Saturn في بقلبه rocks and ice, and then look, this is a satellite, this is a satellite, this is a satellite, this is a satellite, this is a satellite. They are all orbiting around Saturn. So these are the satellites of Saturn. بعد في كتير. Remember, Saturn عنده more than 70 moons. But some are small, some are larger, and each one has and will have different properties. More images of satellites in our solar system. يعني really, if you think of it, هولي شكلهم, they are just like planets. They're just smaller, and they orbit the planets rather than directly orbiting the sun. هذا definition of satellites. This is an example of one of the satellites about Jupiter. It's very active geologically. لما أقول geologically active يعني عنده volcanoes. These are the signatures of volcanoes. See, it is really active. كله كان volcanoes at some point. This is the image of Enceladus, one of the moons of Saturn. I don't see any volcanoes here, but you see gases coming out from this planet. And this is a very important observation when it comes to Enceladus, because these gases are still puzzling scientists. We believe that these gases are results of reactions taking place underneath the crust of Enceladus, يعني بقلب Enceladus. We believe there's water inside, and there's some kind of an activity between the water and who know what else. and this activity is causing those gases to escape from Enceladus to space. So yeah, I'm just showing you different moons in our solar system. Here you can see many moons in our solar system. تذكروا solar system في hundreds of satellites. Yeah, and these satellites برجع بقولكم يعني they are just like the like planets. So بس نقول إن إحنا عنا 8 planets. I don't know how accurate this is لأنه we really have hundreds and hundreds of planets in the solar system. But we have chosen to name the 8 largest bodies بالsolar solar system as planets. So هيدا نحنا قررنا. But yeah. Yeah, so I still want to talk about لهون نحنا we are done with what makes up the solar system. The sun, of course, أول شيء. حكينا عنها before, not in this lecture. We talked about this before. Yeah, the sun, the solar system is made from the planets. حكينا عنهم هلا. For inner planets, for outer planets, we talked about the differences between them. We talked about asteroids, the asteroid belt, the Kuiper belt. We talked about trans-Neptune objects يلي هن بالكوبر belt. We talked about the comets. We talked about satellites. هو كلهم all together combined make up the solar system. Okay. We're gonna talk in chapter 16 intensively about the sun, so don't worry about that. Now the remaining part of this lecture is about how can we really study the planets and the satellites and the objects in the solar system. يعني how can we get information about those objects. The most basic method anyone would think about is if I want to study the moon, then I can send a person to the surface of the moon, and that person, that scientist, would study the surface of the moon. Similarly to Mars, Jupiter, Saturn, وكل الplanets and the asteroids and the trans-Neptune objects. The problem is it's very challenging to send anything to any of those objects. يعني مع كل science that we have developed today, we've only landed on 4 places. Earth, well, 5 places. Earth, well, we are here. Venus, we have landed on Venus. You can see the surface of Venus here. But a rover has landed on Venus, not a person. We've landed on the moon, right there, the structure of the moon. We've landed on Titan, on Mars, on few asteroids and comets. But just to stress this out, when I say we landed, I do not mean humans have landed. I mean we have landed rovers on those bodies. Human only landed on Earth and on the moon. كل شيء تاني rovers. And just look at the surfaces of these planets. They look like Earth somehow. Look at the moon. يعني شو فرق بين المون والأرث غير إنه في ماي. Look at Venus. I mean هاي فيها تكون مثل الصحراء. Look at Mars. Similarly, you can find many places on Earth that looks like the surface of Mars. مشان هيك guys, we always tend to believe that the entire solar system was formed from the same, in the same way, and we are sure about this. What we aren't sure about though, هذا شيء ما خصه بالهيدا in this chapter, but what we're not sure about is the water here. How did the water form on Earth? Did it form on Earth anyway, or did it come from an asteroid? No one really knows yet. So yeah, to take you back, اللي عم نحاول نحكيه هلا in this section is how can we study those planets? How can we study those moons, those asteroids, those comets? Look, we've also landed on asteroids and comets, and this is very difficult to do. But anyway, so for us to study those objects, we have 2 ways. We either send machines and rovers to those places, but obviously it's very hard, very complicated and very expensive, but it's very good way to do this. Or غير إنه we go there and land on them, we do spectroscopy. يعني we point the telescope we collect the light coming from those planets or from those satellites or from those asteroids. We study the spectra of light, we study the absorption and the emission lines of those objects, and if we study the absorption lines, we can tell what chemical compositions, what elements make up those planets. And this is very similar to what we have talked about in chapter 5 when we talked about absorption and emission lines. Please go back there and refresh your memories about it. بس أنا هيك I'm gonna briefly explain this again. Very simple example بيكون if you look at a leaf, it's green in color. So when you look at colors يعني you're doing spectroscopy. شو يعني a leaf is green in color؟ يعني this the atoms and the molecules that make up this material, it absorbs all colors and it emits the green color. If I know what this leaf is doing, what it is absorbing and what is it emitting, I can tell you what makes up that leaf. And this is exactly what we do when it comes to planets. هرجع لورا. This is Earth. I point my telescope from Earth to Titan مثلا, and I collect the light coming from Titan. I draw the spectra of Titan. I look at the absorption line, and every absorption line I see coming from Titan will give me information about what makes up the satellite Titan. If you are not following me on this one, you guys have to go back to chapter 5. يعني مثلا, this is Europa. This is one of the moons of Jupiter. When we look at the spectra of Europa, this is what we get. This thing in pink, in purple, ما بعرف شو هاللون. Anyway, so this is Europa. It has an absorption line here, there, and there, and there. So انتو ما بتكون تحفظوا الابsorption line. انتو you wanna only look at the pattern that the light coming from Europa does. So it's this thing in purple. Now when we look at the spectra of ice, it is in blue. The spectra of ice is very similar to the spectra of Europa. So I can tell you that Europa has ice on it, لأنه the light coming from it gives me the same signature as ice on Earth. This is the meaning of spectra. Spectroscopy, يعني تحطوا telescope, you study absorption lines, you compare the absorption lines with material that we already know of. لما يطلع في absorption lines similar to a material that I know, I can directly tell إنه this planet, this satellite, this asteroid, whatever it is you're looking at has that material. Okay? Please, you have to understand the concept of spectroscopy, and we have intensively talked about this in chapter 5. But في one thing that I have missed talking about, remember إنه these planets and satellites, they do not emit light, they reflect the light. So لما يطلع الضوء from the sun all the way to Titan, right there, I have some absorption happening in this region. And then the light will be reflected from Titan back to Earth. So I also have absorption at Titan, and I also have absorption here at the surface of Earth. اللي عم قلكن إياه إنه when you get spectra of a planet, you should know that you will have also absorption lines coming from the sun and from Earth itself قبل ما يوصل على التلسكوب. Now this is easy to correct because we know what absorption lines في on the sun, we know the absorption line on Earth. So فينا نعرف شو جاي من الsun والearth وشو عن جد جاي من Titan. Because what I care about is what really is coming from Titan, something like this in the Europa's case. So yeah, this is the idea of spectroscopy. Remember نحن عم نقول إنه for us to study objects in the solar system, we either land on them or we do spectroscopy for them. I just show you images for some of the planets, gaseous planet. Well, this is a gaseous planet, Jupiter. Everything you see on Jupiter really are nothing but gases or clouds orbiting and circulating around the planet. We can never see the interior of Jupiter لأنه it is surrounded by clouds. Yeah, and this is a storm happening at the surface of Jupiter. It moves in different directions. إذا بتطلعوا today on Jupiter, you're not gonna see exactly the same structure. هيكونوا هول الclouds مشوا, just like clouds move in the atmosphere of Earth. If you look at Mars, it's red planet. If it's red, يعني in the spectroscopy, it will tell me why the planet is red. It will tell me what atoms or material makes up the surface of Mars. إذا بتفكروا شوي بالموضوع, if you think of an iron which gets rusty, it يعني iron that gets rusty بيصير لونه هيك شوي أحمر. And this is similar to what we observe on Mars. Think of Mars هيك كأنه كوكب مصدى. Yeah, this is really it. But anyway, this is a volcano here يلي صار من قبل on the surface of Mars. This is a polar ice cap. Polar ice caps also on. So Mars has this red material. It had volcanoes. It also have lots of ice. Okay, so هيدا about how we study planets. بعد في شوي in this chapter we're gonna talk about the craters and the appearances of planets and satellites. Everything in the solar system, حتى even the asteroids that we have seen earlier, they have craters. ليه؟ لأنه كل planets in the solar system were bombarded with asteroids all the time. لما أطلع على Mars, I see a crater here, a crater there, a crater. This is a crater inside the crater. Yeah, this is a crater on Earth. This is craters on the Moon, on Mars, and so on. When ما نطلع بالsolar system, we do see craters. Craters are, as I just mentioned, are results of collision of asteroids on those planets. We have thousands of them on Moon, يعني بنقول lunar craters, and they have different sizes, between 1 kilometer and hundreds of kilometers, or even less. This is not very accurate, but they come in different sizes, different shapes, and all around the planets and the satellites. Okay, yeah, and sometimes when we look at planets, we don't see many craters on them. Sometimes when we look at other planets, we see many craters on them. As an example, when you look at the Moon, you see lots of craters. When you look at Earth, you don't see many craters. It doesn't mean that Earth wasn't bombarded with asteroids. It only means that planets that do not have craters today, they had craters back in the time, but those craters were covered up. Let me reword this. Let me start with the Moon. When we look at the Moon, we see many craters because it has been it collided with many asteroids. But since the Moon is not active, since the Moon is inactive, ما في volcanoes, ما في rain, ما في storms, there's nothing happening at the surface of the Moon, those craters will stay there forever. لأنه it's not active. أما in the case of the Earth, مظبوط, we cannot see many craters on Earth, but Earth had so many craters before. But because it has volcanoes, because it has rain, activity, atmosphere, storms, tornadoes, and so on, trees, life, كله هيدا, because it has activities, هول اسمهم activities, those craters have been covered up. So the Moon, the Earth did have lots of craters, مثل كل planets, but they were covered up. Okay? When a volcano erupts مثلا, it will cover those craters. هيدا الidea of why some of them have craters while others don't. One more thing, when a planet has volcanoes مثل Earth, and is a true planet and you see it has volcanoes, you can directly tell what is at the core of those planets. لأنه volcanoes would only occur on a planet if a planet has a liquid lava core, melted lava core. So when I look at a planet and I see volcanoes, دغري في يقول إنه at the core of that planet I have liquid lava core. If I look at a planet that doesn't have many craters, I can directly tell that this when I look at a planet with no volcanoes, في يقول إنه the core of that planet is rocky and it doesn't have liquid lava core. Okay? Why is this important? لأنه if a planet has volcanoes, one more time, if a planet has volcanoes at the surface, وهذا الشيء فينا نشوفه directly, يعني it has a liquid lava core. If it has a liquid lava core, يعني it has a magnetic field around it. If a planet doesn't have liquid lava core, it doesn't have volcanoes, يعني it doesn't have a magnetic field. Our Earth has a magnetic field. Magnetic field, يعني think of Earth as a big magnet. A magnet will have magnetic field lines around it, and this is exactly the case of Earth. لأن Earth عندها volcanoes يعني liquid lava core, يعني that liquid lava core will cause the magnetic fields that you see in this image as an example. If you want to know if a planet has a liquid lava, you look at the volcanoes. If you want to know if a planet has magnetic field, you look at volcanoes. إذا عنده volcano يعني عنده liquid lava core, يعني عنده magnetic field. If you want to measure how much this planet has magnetic field, the strength of the magnetic field, يا أما بتطلعوا على volcanoes, or you send a spacecraft, a satellite, to pass next to the planet and to measure how much magnetic field this planet has. So كمان في two ways to measure the magnetic field. This is an example of Cassini, which has been sent to take images for many of the planets, and it has a magnetometer, which you can see right there, magnetometer high. Those satellites would go to the planet, بيبرموا حواليه, and this magnetometer will measure the magnetic field lines that we have seen here. يعني مش بس I can look at the planet and look at volcanoes and tell إذا عنده أو ما عنده magnetic field. I can also send a rover or a satellite to measure the strength of the magnetic field. Yeah, so this was the chapter 7. نحن حكينا عنه بالصف already, and here I am posting the first chapter, chapter 7. The next chapter will be chapter 8, where we're gonna discuss a bit about the formation history of the solar system, كيف خلقت الsun والplanets. هذا الشيء بتعرفوه, I hope so. And we're gonna talk about the methods that we use to find exoplanets. Yeah.